All right, and I'm very excited to introduce the next speaker. It's Rodney, who will tell us about going React with React extensions and UI. So Rodney.
How you doing? Welcome to .NET Conf, and today we'll be talking a little bit about going reactive with reactive extensions and reactive UI. So let me load my presentation and share my screen, sharing my desktop, sharing the PowerPoint, and off we go. So I am a maintainer of reactive UI. I'm sorry, going reactive. So I'm Rodney. I'm a maintainer of reactive UI. I'm a .NET Foundation member, and I'm a Microsoft MVP. And today I'll be talking to you about going reactive with reactive extensions, reactive UI, and why you would want to use that in a mobile application. I'm going to start with a brief history lesson, some concerns that mobile developers face, a little bit of a demo, a shameless plug, and give you some takeaways at the end. I am sharing. It says share desktop. Hold on. Desktop. Now can we see my screen? Okay, and you can hear me now too, yes? All right. Wonderful. So I won't bore you again, but I'm Rodney. That's me. Here we go. So in 2007, .NET 3.5 landed, and with it brought LINQ, language integrated queries. That was C#'s first step towards adding functional elements to the language. It allowed SQL-style functions to be parsed over collections like objects, SQL, and XML. 2009, RX.NET was created. Eric Mayer and Wes Dyer pretty much broke the world. While working at Microsoft, they stumbled upon a monad, and they realized that if there were pull-based collections, that there had to be push-based collections. In 2010, Anais Betts created some extension methods using reactive extensions for MVVM in .NET applications. So the interfaces that you see are first-class citizens in the .NET space, right? On the right, you see your IEnumerable and your IEnumerator, and on the left, you see IObservable and IObserver. When you traverse a list in .NET, you are using the IEnumerator interface to get the current node, to move to the next node, or to reset to the initial position of the list. And that creates a pull-based collection. It pulls in a certain amount of data and doesn't change unless you explicitly mutate it. If you've ever seen the yellow squiggly that says multiple possible enumerations, this happens because the enumerator could reset once the list mutates, and if you're not explicitly to listing, you'll end up starting back at the beginning of the list and having extra traversals of the list. IObservable is a push-based collection. This works well with technologies like SignalR, real-time events, and asynchronous programming. The observable allows you to subscribe, which basically allows any observer of the observable to process and read values from that list. An observable is really a collection of things over a span of time. You have onCompleted, which is a notification that lets you know that there are no more elements coming on the list, and on error. So if the list errors in the middle of processing, you'll be able to catch the error and handle it accordingly. And on next, where you can explicitly act on whatever the next value is on the list. I want to point out that this is similar to the Gang of 4 publish subscribe pattern. And a great example of an observable is a Twitter stream. You have many people watching the stream. You have stream constantly updating and pushing new data to it. And all subscribers have the opportunity to act on any value pushed to that stream. So I know most people think that reactive extensions is this evil wizardry. And I will tell you that I've had people look at the code and say, it looks like magic. And I'll tell you, I agree, it is magic, but it's composable. You can compose parts of queries the same way you could do with an IEnumerable and branch various observers to do different things at different positions in the query execution. It's declarative, so you declare what the code should do and it will just do it. It's reactive. When the state changes, the code will just fire off. And it's readable. It's very human readable because it uses link operators. Reactive extensions themselves are across a lot of different languages: Java, Go, Swift, JavaScript, Kotlin, and PHP. Even PHP uses reactive extensions. But reactive extensions is really all about collections. So I've got a quick video that I want to play that kind of explains what I want, or what I think reactive extensions are. And I know that there's no audio for this video, but this is a very good point. And I'll go ahead and pause because we've just errored, as you can see. We've hit the on error condition. In this example, the conveyor belt is basically the observable. It's a collection of things that are happening over time. The chocolates represent events or tasks that are happening, and Lucy is an observer of that observable. She's able to pick chocolates off the conveyor belt and act on them. She's able to put them back on the conveyor belt. And this is a great example to me because events happen fast. We need to respond fast. And maybe we need to group the events, maybe we need to batch the events, and maybe we need multiple people observing the events in order for them to be successful. So I'll go. So what does this have to do with Xamarin and mobile? As mobile developers, we respond to events. We are constantly using the commanding pattern to create event handlers that will do work in our view models. We're trying to avoid memory leaks. We have limited resources. We have a managed runtime that we have to deal with in Xamarin. And iOS, as many of us probably have already seen, will crash your application if you exhaust the memory that's available. It's also recommended that we use Xamarin Profiler before every release. But let's be honest, who does that? You just wait for the inevitable crash, and then you go look for logs and try and scramble and figure out what's going on so you can push an update to your application. Asynchronously loading data. We need to load data when the page loads because unlike web, there is no global application state. So when the page loads, we need to call out to an API and get more data. And we have to handle disconnected state. No internet, no problem. Your application still has to function and it still has to work in a disconnected state, and you as the developer have to respond to that state change. So how many of us have ever seen this? This is a basic Xamarin search bar with a text changed event handler, and we're providing it some delegate. The problem with is that the delegate isn't cached. So if the delegate isn't cached, you can't properly dispose of the delegate. And because there's no explicit reference in memory to the delegate, the garbage collector won't reclaim that memory. So what happens? It leads to memory leaks. The three main things that I think developers need when handling events are event handlers, which are basically callbacks. Callbacks you can do separately if you want to, and then deallocation. And I think deallocation is the thing that we struggle with most because it's a question of how do we properly dispose of objects. So what if I told you that this is basically link over an event stream? System.reactive provides a way to convert events to observables. This is effectively link over events, just like you would have link over objects. Just like you would have link over an IEnumerable, you could have link over an IObservable. This particular code sample will delay the processing on a set of events. It will process this off the main thread, which is important for Xamarin developers because if we do too much processing on the main thread will lock and our application will crash. It allows us to select the state, only select state that has changed, verify that there is an actual value to process, we're also telling the code to return to the main thread when we're done executing. We can invoke a delegate, and then we can easily dispose of this entire process when we clean up our view bindings. So let's look at some code. That's not the right one. There we go. Let's close that down. And look at some code. So first I'll talk about what you do in a non-reactive scenario. In a non-reactive scenario, you would create some search bar, which is just a Xamarin Form search bar with a text changed event, and you would give it some, hopefully, cached delegate. Then you would have to explicitly dispose of that cached delegate at some point in the future using the dispose method. Standard iDisposable. The problem comes in with this delegate itself. If you'll notice, we are responding to every single text changed event that happens during execution, which means every time the user of your application types in a letter, we have to then go execute our search command. This can become process intensive. It can lead to too much HTTP traffic over a very small pipe, and it doesn't lend to a great user experience. Now you can write your own code around it and write a buffer and do all of these things, but that's additional code that you have to maintain and hopefully unit test. But in a reactive scenario, I can take my event, my text change event, and wrap it in an observable. So the system.reactive allows us to take an observable from an event, provide an event handler, allocate and deallocate memory all in one succinct block of code. So now, again, I said earlier that observables are composable. I've now composed an observable of text changed event args. I'm again gonna okay, let's see if we can do that. I think it's control. Yeah, I'm hitting the command plus and it's not doing the thing. Let's just go ahead and let's go to preferences and bump font, which I had it set. So let's look at where's font, text editor, general, grab below key bindings, fonts. So let's set to the font. Let's set to size 18, see if that works better. Okay. I guess not. Okay, let's try 24 then. All right, is that better? Hopefully. Let's hope that that's better. Okay, good. So again, what we're doing is throttling and saying we only want to process events 750 milliseconds after the user stops typing. And we explicitly want to look at these events on a different thread than the main thread. We're explicitly making sure that it's distinct and that it won't change. We're selecting it out and then we're processing it. So let's go ahead and run this code, and that way I can show you that it's not really magic. It's just a different way to look at programming. So, all right, that's all good stuff. Let me pull up. All right. So I have a standard search bar, and this is plugged up to a DuckDuckGo implementation so I can get information from the web. So I'll go ahead and start typing in Xamarin. As you see, I'll execute the search query. Oh, there we go. Now it's doing special things. I'll execute the query. It'll happen twice, but there's a reason for that, which I'll get to later. And you'll see that I've got a list of responses. Now, I want to point out that, again, I said there's a distinct until change on it. So if I go back and hit N again, you'll notice that the search query doesn't get executed again. But to prove that I'm not a liar, I'll fat finger it. And now you'll see that the query execution is actually happening again. Now, it shouldn't provide any actual values, but this shows that we can defer execution of events that happen from our UI toolkit being Xamarin, and not have to process everything. We can use LINQ that we know and love and have been using since 2007 to functionally react to code, or better yet, functionally react to what the user is providing us. So I'll go ahead and change it again so we can watch the search query execute. All right. And I'll go back to the code again because I want to point out a couple of things. A lot of people will say, and I say myself, that this is a lot of boilerplate code. And I agree with you 100%. So the reason why my search query was running twice is because of this chunk of code right here. This is an actual Xname to the search bar in my XAML, and I am using a package called Pharmacist, which is under the Reactive UI umbrella. It was created by Glenn Watson about a year or so ago. And what it does is takes all of this boilerplate code that it takes in order to wrap events and does it for you. So anything in the Xamarin UI toolkit that has an event gets wrapped using this events. So all I have to do is name my element, look at the events on it, and then I get an observable that is the text change events for that particular UI element. And this cuts down on a lot of time. It cuts down on writing a lot of boilerplate code, and it is makes it very simple to start getting in and using LINQ to events. So we'll go ahead and go back. So the other thing that observables are asynchronous. They are awaitable. You can use the async and await syntax. They can be scheduled on specific threads. So not just configure await false. We can actually say, use it on the task pool scheduler, do it on the immediate scheduler, do this on the UI thread. And they just emit values over time asynchronously. They are awaitable, like I said, because you can actually use it with the TPL that you're used to. So the async and await operators are valid with observables. And observables, they return iDisposable. iDisposable is important because it allows us to clean up resources. Again, we're trying to prevent memory leaks. The reactive extensions provide a way to model asynchronous programming and dispose of their resources very cleanly in a way that the task parallel library does not. But you can use it with the task parallel library, and if you've been programming as long as I have, you remember the old wild, wild west where you had callbacks and commands and delegates all over your code, and you didn't know where anything was or what was going on, and it was very spaghetti. So as a Xamarin developer, how many times have you had to load data asynchronously, or load data when the page or the view model is created, or load data to a list view? Reactive UI has an interesting story for loading data. There's no need for async void in your constructor. It's bad, don't use it. There's no need for doing any type of asynchronous programming in your constructor. We can actually load data in response to the view model's initialization. Further, I'll say that dynamic data has an interesting story for view model creation. It provides lists and dictionary style collections, and dynamic data is another library in our ecosystem. It allows you to propagate changes from the list as a set of change sets. It has standard link operators, and it also has some custom filter and transform operators. And candidly, dynamic data is everything I wanted observable collection to be, but it just never really panned out. So let's go look at some more code. And first I want to pull up what you'll normally see, or at least what I've seen in a lot of Xamarin applications that I've inherited, things that I did before I found reactive extensions and reactive UI. But I did this, which is very common. I use async void because a task return type will immediately cause type issues, and this works. But there's a problem. Async void is not actually good for our code because void is the absence of a return type. And the TPL doesn't actually give us an aggregation of the errors in the event that the task fails somewhere along the way. So an alternative way is this code right here. What I'm basically doing here is using Reactive UI, one of the extension methods that was originally created as part of the library, and I'm saying when there's a value in the view model. So anytime that the view model has a value and the view model is not null, I'm going to explicitly change it out to a notification, because all I want is a notification that it's happening. I don't actually want to process on the change itself. I'm going to look at it on the main thread, and I'm going to invoke a command. And then again, I'm going to dispose it with my nice view disposal bindings. So what this does is allows us to lift the concern of creating an asynchronous task in our constructor, and when the view loads and it creates its binding context, it will then go and generate the call and get the data. This is an extremely useful use case. This is probably one of the use cases that attracted me to reactive extensions and reactive UI, because I was doing a lot of async void, and then I read that async void is bad, and I had no idea how to do it because constructors don't allow for asynchronous methods. And I wanted a way to load the data when the view model is loading. So I'm going to segue into pointing out that this data load is basically just an implementation of a SignalR connection hub. I don't have it wired up to an actual connection right now because demos are hard and I didn't want to accidentally break the world. But you can see here in this class that the mock that I have is going to respect the exact same interface or abstract class. And what I'm going to do here in a real scenario is I'm going to connect using the connection string. I'm going to create my hub builder with that connection string. And whenever a value is pushed to me from SignalR, I'm going to add it to my dynamic data cache. But the way I'm going to do it is a little bit off. I'm not exactly going to put it directly into my cache because, again, I'm trying to separate my concerns. I'm using a subject, which is both iObserver and iObservable, and I'm going to push data onto my stream using the onNext method that we saw earlier. So effectively what I'm going to do is anytime something gets pushed from SignalR, I'm just going to tick a new value on my observable. This is asynchronous, and it's relatively easy to set up. So let's go look at the view model itself. The view model is going to have an injected iOrder service, which is going to have a connection hub client in it. And all I'm going to do is look at my observable cache, which is the dictionary implementation in dynamic data, and I'm going to connect, publish, and ref count, which these things are beyond the scope of this talk. I've got a blog post somewhere where I talked about these things. And then I'm just going to transform my DTO to my list view item. And this is very clean and very straightforward versus some of the code that I've seen in my past where I've got a function, and in the middle of the function I'm newing up some data, and then I'm newing up a view model, but only certain times. What this does is allows us to react to the fact that values are being pushed to us and then transform those values and display them on screen. I'm going to bind out to a read-only observable collection, which is just a fancy observable collection, which is then bound to my view, and everything is going to be great. So let's go ahead and run this code. Let's see, that's no reactive, so let's close that. And let's execute the thing. So the usual business domain that I use for demonstrations and code samples is coffee, because I drink a lot of coffee and I like coffee. So what you'll see here is basically just a list of orders that are being generated from a mock that are being pushed to my code. And as you see, the view models are just updating. So every time a value is pushed to the source cache, I am basically transforming it out. It's getting bound out to my read-only observable collection and automatically getting populated in my list view. So I've got it set right now to push me one maybe every 750 milliseconds, but you can imagine using something like this for any type of SignalR, any type of real-time eventing, any type of processing where you are going to be getting a stream of values that you need to process. Stop that, and let's go back over here. So we get to the part where I'm going to do some shameless plugging. This is the Reactive UI team. We are part of the .NET Foundation. There's some alumni team down at the bottom, as you can see, people who I've learned from and continue to learn from. But the main thing that I want to talk about now is kind of what I want to talk about is where we can actually be used. We have packages that are usable in Xamarin.Forms. We actually wrap Xamarin Essentials, Xamarin.Android, Xamarin iOS, Xamarin Mac, Tizen. We even actually have Blazor support. So we are found in any place that you would want to use Xamarin to develop a mobile app. You can use Reactive UI. If you want to do it at a Xamarin Android level and you want to do a Xamarin Android project, Reactive UI can support you. If you want to do Xamarin Mac, Reactive UI can support you. So now I'll talk about some of the shameless plugging and some of the takeaways. So Reactive UI is just MVVM niceties on top of your UI toolkit. Most of the magic comes from reactive extensions, and a better understanding of reactive extensions will help your understanding of how to get more value out of Reactive UI. Pharmacist, which is the logo on the left, is a clean way to cut down on boilerplate so that you can use link to events and wrap and dispose of your event handlers easily and cleanly. It works at compile time, so you have all of the niceties around compile time. And it's a very simple way to get started with reactive extensions. Dynamic data, again, it's what I thought observable collection should have been when I first started. It allows for encapsulation of the data logic, so you can actually lift a lot of your data logic out of your view model and put it in a service and just allow dynamic data to present the data to your view model. It will clean up a lot of code. It'll make things a lot more testable and a lot easier for you to deal with. Some of the main things that I see when people approach reactive extensions and Reactive UI is that they want to use Reactive UI without actually adopting reactive programming. You can do this, but you would be leaving a lot of value on the table. People won't approach it because it's functional, and functional has a very negative connotation in the .NET space. But the main thing I see is once people understand that it's really just link over events and they start using it and see the power of it, they won't want to do anything else. The biggest misunderstandings that I see about Reactive UI is Reactive UI is not React. It's not React.js. Reactive UI is just extension methods on top of .NET reactive extensions so that you can have MVVM niceties. You can use as much or as little as you want. We work well with a lot of the other major MVVM frameworks because it's a very much play as you pay model where you can just take the parts you need and leave the rest behind. You can use Reactive UI without using reactive extensions. And furthermore, you can use reactive extensions without actually consuming Reactive UI. But again, from an MVVM perspective, it makes it a lot easier to deal with things. And the main difficult change that I see for people when they get started with reactive programming is the fact that we define all of our logic in the constructor. And people say that they want clean, human-readable code. Well, what better way than to encapsulate all of your business logic directly in your constructor? It gives you a single source of truth. You don't have handlers here and callbacks there and region tags to help clean everything up. Everything's in the constructor. And you are creating composable bits that will react to state changes as opposed to you having to imperatively change that state. There's a book. There's a book called UI and Reactive UI that was written by one of our alumni maintainers. In it is a lot of valuable information around how to get started with reactive extensions and reactive UI. A lot of different scenarios and code samples are provided around how you would do things like create a timer or change view components based on events or run animations based on events. And we exist in a Slack channel, reactiveui.net/Slack. So if you want to get involved, if you want to see what this is about, if you want to get started using link to events and understand what power you can wield using this paradigm, I recommend you joining the channel, ask your questions, and we will do our absolute best to help you. But the main takeaways that I have for you are using dynamic data to load data and transform can clean up your view models a lot. Using Pharmacist to generate the events can reduce a lot of your boilerplate code when you're trying to react to events. And honestly, I would say don't fear observables. Just understand that it's just another way to do link over a different collection type, and you can use it to get started down this functional path. And it's very much like Pringles. Once you start, the fun doesn't stop. So I am done. Ready for questions?
I think it was like reactive UI.
Reactive, yeah. Right.
Ready for questions?
All right, Rodney, thank you so much for the talk. And we have a feedback that was a nice presentation. Now I really need to play around with Reactive UI. So great job. Yeah, that came from Xsignal. And we have a few great questions. So the first one is from Jean-Marie. And the question is, Reactive UI seems great for that search example, but is it really useful in most of the apps when 95% of your screens are loaded just once, when you have so few updates messages?
That's a great question, and it isn't as useful when you aren't doing a lot of eventing. But I've seen a lot of people and a lot of programs use a lot of events. The average Xamarin screen that I see has anywhere between 5 to 10 events and event handlers. So if you're doing event-intensive programming, I would say reactive extensions and reactive UI provides a lot of value. If you don't have as many events and you don't need to respond to events as often, then it may not provide as much value to you.
All right, great. The next question is from Scott Baker, and he would like to know what is the difference between LinQ's select and reactive UI's transform methods.
So that's actually a dynamic data extension, and there's not a lot of difference. It's really just a library-specific way to do the transform. So you could do the same thing using select, but we use it internal to dynamic data because there's some additional niceties that happen under the hood. So, if you find me in Slack, we can look at those code samples and we can kind of talk through that a little bit more if you'd like.
I see. All right, and the next question we have from Aishi Birthday, and the question is, what kind of design patterns are you using? So people are curious about different design patterns. Can you give any suggestions on that area?
So design patterns like Gang of Four design patterns, I'm really kind of more following solid here, where I'm injecting a service into my view model. That service happens to just provide data. So this isn't probably what I would consider a known pattern. This is kind of a pattern that I've started to evolve, and other people I know in the reactive community have started to evolve around dynamic data. Because of the way it works, I can actually, instead of injecting my data service injecting my database call into my view model and getting data out of the database, I can wrap that in a service and lift that work out of the view model and just allow the service to provide me an aggregation of data. So I'm taking the concerns of calling the database or calling the API or doing any of that work out of my view model, putting it in a service and then allowing that service to propagate data to my view model, because really the only thing my view model cares about is data.
Excellent. Excellent. Thank you, Rodney. All right. Thanks for your great talk and excellent answers. And now we're gonna make a 5-minute break so everyone can grab lunch or relax a little, and we'll be back with you in 5 minutes. Thank you.
Okay.